Hello everyone, my name is Joshua Olusegun Ejitomobi. It's quite a while. I hope all is well with every one of us. Today I want us to quickly look at how to use R for some financial calculation. And we're going to be looking at how to use R for calculating future values, present value, net present value, and internal rate of returns. For details of all these financial performance measures, we can actually maybe read some very good textbooks on financial appraisal. There are quite a lot of them. So we'll be making use of FinCal package. So here we have library FinCal to load the package, run it. Then to calculate future value, I want us to consider this example. Assume you have just invested 100 Emalangeni in a saving account which earns 6% interest compounded annually, and you would like to know the future value of the sum after 3 years. Very, very simple to do. The function is FV. Then you start with the compound interest. Here is 6%. Then the number of years. Then the present sum invested. But don't forget to add negative to the present sum. So we have FV 0.063 minus 100. Run it. So the future value of the sum after 3 years is 110.10 Emalangeni. Very straightforward. Now there is this question. What is the future value of 1,000 Emalangeni deposited in a saving account at 5% interest for 10 years? Then we calculate the future value at 7%, 10%, 12%, 50%, and 80%. Just follow the procedure I illustrated above, changing the percentages. The number of years are the same. So let's run everything. Yeah, you can see the changes in the future value as the compound interest keep changing. Now let us look at the situation of annuity. Suppose 1,000 Emalangeni deposited at the end of each year in a saving account, which pays 6% interest. Calculate the future value of this investment at the end of 3 years. This is a case of annuity because the present sum is deposited at the end of each year. So to calculate it is very straightforward. We just add point annuity to the FV. So every point annuity is the function. The procedure remains the same as we've been doing before. So here we have FV annuity 0.06, which is the compound interest. Then we have 3, which is the interest. I'm sorry, it's no compound interest now. 3, then minus 1,000. Yeah, run it straightforward. So to practice, suppose 100,000 Namalangeni is deposited at the end of each year. The savings account which pays 5% interest. Calculate the future value of this investment at the end of 5 years. Recalculate at 2%, 8%, 8%, and 10%. So let's run everything. And you see the way it's changing. Now let's quickly look at how to calculate present value using an example. Find the present value of 1,000 Namalangeni to be received in 5 years using an interest rate of 8%. So in this case, we have the future value to be 1,000 Namalangeni, then we want to calculate what the present value will be. Then we have 8%. It's the same thing. The only difference is that the function now is PV. So let's run it. Fine. So this is showing you that the future value of, if the future value is 1,000 and at 8% interest and 5 years, we have the value at present to be 681 Namalangeni. Also, in order to try other examples, find the present value of 10,000 Namalangeni to be received in 5 years using an interest rate of, just changing the interest rates. So you run everything, and you see how the present value keeps changing as we change the percentages. And just as we have annuity in case of future value, also we can have annuity in case of our present value. Suppose an annuity of 1,000 Namalangeni will be received at the end of each year for 3 years, and the interest rate is 8%. Calculate the present value of the income stream. This is a situation of annuity. Just like before, we just add point annuity to our PV function. So let's run it and see the present value of the income stream after 3 years. That's straightforward. So let's look at other examples. Another line. Suppose an annuity of 10,000 Namalangeni will be received at the end of each year for 3 years. At interest rate 5%, calculate the present value of the income stream. We calculate the present value the annuity is received at the end of 5, 7, 8, and 10 years. In this case, we see we'll be changing the years without changing the percentage. In this case, we calculate the PV if the interest rate is 3%. In this case, the year remains 3, then we keep changing the interest rates. Very simple. So, and it's just what we have here. So let's run everything. Super simple. Super simple. Super simple. So let us now look at real investment appraisal. And we're going to be looking at 4 different methods of investment appraisal. The payback period, simple rate of return, net present value, and internal rate of return. Let's use this example. The cash flow for investment of 10,000 by 2 investors are A, 3,000, 3,000, 3,000, but The cash flow for the second investor is different from that of A. Here we have 1,000, 2,000, 3,000, 4,000, and 5,000. So we want to calculate the payback period, simple rate of return, net present value, and internal rate of return. For payback period, very, very simple. Calculate the average cash flow if the cash flow is the same over the years. For instance, for the first investor, it's 3,000, 3,000. So which means the average would be 3,000 multiplied by 5, divided by 5. So which is going to give us 3,000. So, and the payback period will now be what? The payback period will be 10,000 divided by that. So that's P, let us call it P1. So it's going to be 10,000 is the amount of investment, then divided by 3,000, which is the average cash flow. So that will give us 1/3 years. That's 3.33. Anyway, let's run it so that I'll not just be using my head. So that's PB1. Let's run to get 3.33. That's good. So, but in the second one, we see that the cash flow keeps changing over the years. So in that wise, we need 2 stages. The first one is to calculate the cumulative sum. I call that one CCF. Yeah, I have cum sum, C, then this is the cumulative sum. Then after that, you have a situation whereby if you add up, you are going to get that 10,000. Here you have 10,000 amount of investment. Here we have 1,000, 2,000, 3,000. It's in the 4th year. This is very simple to calculate manually, but you know, if you have so many years or you are dealing with fractions and so on, it will be difficult. So it's better to use this is the code. This is the code here. We have minimum which CCF greater than 1,000 minus 1, so that we want it where the add up is 10,000. So if you run this, for instance, it's going to give you 4 years straight away. Yeah, that's 4 years. So for simple rate of returns, let us assume a depreciation of 2,000. We remove that 2,000 from 3,000, then we have this 1,000. So the simple rate of return will be 1,000 divided by 10,000 multiplied by 100. Just calculate it. I think this is going to give us 10%. Yeah. So, and for the second investment, it's going to give us 12%. Now calculating the net present value, that's very, very straightforward. Now at 8%, this is our cash flow. The function is NPV. So let's run It's investment A. Let's run it for investment B. Very straightforward. Yeah. So it is very clear that the net present value of investment B is actually greater than that of investment A. Internal rate of return, we know that is when your NPV is equal to 0, the rate at the interest rate at which your IRR is equal to 0, which is your marginal efficiency of capital. To do that, very straightforward to just IRR. But don't forget, because this is where many users do make some mistakes. They often forget that the initial capital outlay must start first and must be negative form, followed by the cash flow across various years. So let's do that for this for A and B. Let's run it. Yeah. So which means the internal rate of returns for investment A is higher than that of investment B. This is 15%, and this is 12%. So this is just what I want to share with us today. Super simple and very straightforward to do. And it makes financial appraisal very interesting, no matter the number of years you are dealing with, and no matter how large the cash flow. It's very simple to do. So thank you very much. Till we meet again, stay safe.